All right, we're back. Today we're going to talk briefly about fractions and decimals, which you are pretty familiar with, but I just wanted to walk through a couple things in terms of how we transform different decimals into fractions. So here we go. There are a variety of decimal values. Typically there are less than one that you should be familiar with. Straight away, for example, if you see this decimal 0.25, you should immediately think that's 1/4, and 0.25 is indeed 1/4 because remember what this means to us. Every decimal is a fraction. Here's the tens, this is the hundredths place, so that means we have 25 1/100ths as a fraction. And if I were to simplify that, 25 can go 25 once, and it goes 25 into 100 goes 4. So there is our fractional equivalent. Where it gets somewhat interesting is, well, what happens if we have a repeating decimal that repeats forever and ever and ever? The most famous one is 0.33333 repeating forever and ever and ever. Most of us memorize that as, well, 1/3 as a fractional value. And the reason it comes out to be 1/3 is, notice it's just a single digit repeating, so I could write it like that, really. Okay. And this is a technique we use to transform repeating decimals into fractional values. Because if this goes on forever, well, we would not know what place to place it under. Meaning, like, this one stopped here at 5, so we need to put it over the hundredths place, so 25 over 100. Whereas if this one goes on forever, well, then what would we put over? Over 1 million, over 1 billion, 1 trillion? It would never end. So here's a technique that we use to make this happen. We're going to say this repeating decimal, we're going to say that is equal to some variable called n. Okay? And since this decimal only repeats in one digit, I'm going to multiply this decimal by 10. So if I say 10 times n, that would be equal to, well, if n is equal to 0.3333, on and on and on and on and on forever. Remember, if we multiply by 10, it moves the decimal place to the right one spot. So if this is what n is equal to, then 10 times n will be equal to 3.3333, repeating forever and ever and ever. Alright? And I know to multiply by 10 because I'm only repeating just one particular digit. Okay? We'll see what happens when you if you repeat two digits. So there's 10n. So we said n was equal to 0.3333 repeating. Okay? So if I have 10n equals to this and n is equal to this, well, I have an equation of sorts that I can subtract from each other, two separate equations. So if I subtract downwards, I get 10n minus 1n, that's 9n, equals, on the right-hand side, well, if I subtract 3.333 repeating from 0.333 repeating, I'm left with just 3. And then if I divide both sides by 9, I can solve for n. So when I do that, I'll get, well, n is equal to 3/9 or 1/3. And that's how we get the fractional value equivalent of what n was equal to as a repeating decimal, 0.3 repeating forever and ever and ever. And the trick there was to multiply it by 10 and then subtract the 2. And I said a moment ago, well, what happens if we have multiple decimals being repeated? For example, if I have 0.121212 repeating forever and ever and ever and ever, well, since just the 1212 repeats over and over, another way to write that is 0.12 and then repeating bar over the 1 and 2. So same deal, we're going to let that be equal to n. And notice how it's two digits that are being repeated. So this n is the same thing again as 0.12121212, etc., etc., etc. And This time, since there's two digits being repeated, I'm going to multiply n by 100. And again, if I take this n, multiply by 100, well, if I multiply by 100, it moves the decimal place over, well, 2 spots. If you multiply by 10, it moves by 1 spot, but by 2 spots, 100n is 12.121212, repeating on and on and on. Here's my n value of 0.121212. And again, I have two equations on top of each other. I can subtract the two equations in math. 100n minus 1n is 99n is equal to 12. Because if I subtract these two decimals, well, all the decimals after the point cancel out, leaving me just a 12. And then n will be equal to 12 divided by 99, which can reduce by 3s, so 4 over 33. And that's the fractional equivalent of 0.121212, repeating on and on and on. So there'll be a couple problems in your assignment today that ask you to transform a repeating decimal into a fractional value. And this is the technique that we use. Let n be equal to the repeating decimal, then multiply by either 10 or 100, sometimes 1,000 if there's 3 digits that are being repeated, and then you work this process of subtraction to find what the n value is, and it's pretty simple. And until next time.